The era of superhumans is no longer a sci-fi fantasy. It's already here. From mind-controlled limbs to vision-enhancing bionic eyes, the limits of what humans can do are being completely rewritten. In this video, we're unveiling 7 bionic upgrades that are turning ordinary people into something extraordinary. Stick around, because what's coming next might just reshape the future of humanity. Let's kick things off with one of the most mind-blowing advancements: neuro-controlled prosthetics. These are not just robotic limbs. They're artificial extensions wired directly into the nervous system. That means users can move them just by thinking. No buttons, no levers, just pure brain power. Gone are the days of clunky mechanical devices. Now, prosthetic limbs respond to your intentions almost instantly. One standout example is the Luke arm, developed by Deka Research and named after Luke Skywalker's robotic hand. This arm lets users do complex things like picking up delicate objects, pouring liquids, and even feeling sensations like pressure and temperature. Yes, a robotic arm that can feel. Even more groundbreaking is the amaze system, the agonist-antagonist binaural interface, developed at MIT. It reconnects nerve and muscle tissue during amputation, allowing a prosthetic limb to receive clearer, more natural signals from the brain. Some users even regain proprioception. That's the ability to sense the limb's position and movement, as if it were still part of their body. Many high-end prosthetics now feature gyroscopic sensors and real-time microprocessors for unmatched stability and precision. Need a gentle grip to hold an egg? Or a powerful grasp to lift a heavy toolbox? All with a single thought. This isn't just replacement, it's enhancement. Now let's talk about bionic vision. If night vision goggles impress you, wait until you hear what's already in development. Scientists are restoring sight and even extending it beyond what humans have ever experienced. Take the Argus to retinal prosthesis. It's the first FDA-approved bionic eye designed for people with retinitis pigmentosa. It sends visual signals directly to the brain, giving users the ability to perceive shapes, movement, and flashes of light. For someone who's lived in total darkness, that's life-changing. Over 350 patients around the world have already received it. Then there's Prima by Pixium Vision, targeting age-related macular degeneration, a condition affecting over 200 million people. With this implant, patients can regain enough vision to read, recognize faces, and navigate environments with precision. In some trials, patients reached visual clarity as sharp as 20/100ths. That's something unheard of in previous tech. But the future of bionic vision doesn't stop at restoration. Scientists are now building eyes that can see in ultraviolet or infrared, unlocking entire new layers of perception. This could transform everything from military operations and search and rescue missions to medical diagnostics and industrial safety. Add augmented reality overlays, and bionic eyes become real-time data hubs. Imagine walking through a city and seeing navigation, translations, or hazard alerts all projected right onto your field of vision. A seamless fusion of physical and digital reality. Next up is exoskeletons. Robotic suits that amplify your strength, endurance, and mobility. No longer science fiction, these systems are being used today in medicine, construction, and even on the battlefield. The hybrid assistive limb from Cyberdyne, originally built for rehabilitation, now helps paralyzed patients walk by reading subtle bioelectric signals from their muscles. But it's gone beyond hospitals. In industrial settings, it helps workers lift heavy loads with minimal strain, reducing injuries and boosting efficiency. Another major player is Bionics, whose suits let soldiers and workers carry gear for long periods without fatigue. It's not just about being stronger, it's about lasting longer. DARPA is also developing military-grade exoskeletons to make soldiers faster, more powerful, and virtually tireless in extreme environments. And soon, consumer-grade versions may hit the market, helping everyday people climb stairs, carry groceries, or stay mobile as they age. Now imagine enhancing the senses themselves, hearing whispers across a noisy room, or even sensing magnetic fields. Bionic tech is making that a reality. Take cochlear implants. They've already restored hearing to thousands, but the next generation could let humans hear ultrasonic and infrasonic frequencies like a bat or an elephant. This expands our auditory range beyond the natural spectrum. Researchers are also working on implants that allow people to detect magnetic fields, giving them an intuitive sense of direction, no GPS required. And there's work being done on enhancing smell and taste too. That includes sensors that detect dangerous chemicals in the air or amplify flavor sensations in food. This isn't just recovery, it's evolution. Next is brain-computer interfaces, also known as BCIs. This is where science fiction truly becomes science fact. Companies like Neuralink, founded by Elon Musk, are building implants that let you control devices with your thoughts. No touchscreens, no keyboards, just pure mental command. Early tests have already shown users operating smartphones or robotic limbs just by thinking. But that's just the beginning. Imagine being able to boost memory, retrieve information on demand, or even communicate brain to brain. Of course, the ethical implications are massive. Could someone hack a brain implant? Could thoughts be manipulated? These are questions we need to answer as the technology advances. But the potential is revolutionary. Let's move inside the body. Artificial organs. These aren't just replacements. They're upgrades. The Carmat heart, for example, is a fully artificial heart designed for end-stage heart failure. It's more efficient and reliable than a natural heart and doesn't need a donor. Rejection rates are also far lower. Researchers are also developing artificial lungs capable of supercharging oxygen absorption, helpful not just for patients, but for athletes, pilots, or workers in high-altitude or underwater environments. Artificial kidneys and livers are also in the works, designed to detoxify the body faster and more reliably than organic ones. Now imagine organs engineered not just to heal but to adapt to extreme conditions. Space missions, deep-sea exploration, disaster zones. These possibilities are no longer theoretical. And finally, biomechanical muscles. A breakthrough that could redefine strength and precision. Artificial muscles made from soft robotics can flex, stretch, and contract like real ones. But they're faster, stronger, and more durable. They're already being used in advanced prosthetics and robotic limbs that mimic delicate human actions, from playing piano to typing on a keyboard. Here's the kicker. These muscles can lift many times their own weight and react with superhuman speed. Imagine replacing damaged muscles in patients with degenerative diseases. Not just restoring function, but enhancing it. With all these upgrades, it's easy to get excited. But we have to ask some hard questions. Who gets access to these technologies? Will they be available to everyone, or just the wealthy? Could Bionics create a new kind of class divide? And what about security? What if a bionic implant fails? Or worse, is hacked? As we integrate machines into our bodies, the line between human and machine begins to blur. Are we enhancing humanity or creating something entirely new? These are the challenges of a bionic future. And if we face them wisely, the benefits could be profound. If you've made it this far, let us know your thoughts in the comments. What excites you most about this tech? What concerns you? Thanks for watching and stay curious.